All right, hello everyone. This is Mr. Crocher. I'm going to go over our first practice test. For the test coming up here on Chapter 4, complex numbers. So here's the problems. Here's the answers. Problem number 1 says, pretty simple, straightforward. Write it out. Write this out twice. FOIL it. Simplify it down to here. Number 2, it gives us this polar number that we can graph because I know the angle is at 330 degrees, so it's about right there, and the length of it is 5 root 3. So there's the graph of it, and if you were to put it in standard form, it'd be 5 root 3 times root 3 over 2, and 5 root 3 times negative 1/2, and we'd have this complex number right here in standard form. Again, if it's on the unit circle, look for those values right there. And number 3 says solve it. So I factored out an x first, then I did a little factor by grouping all the way down. And here's my factorized form. You're going to have to circle this. Whoops. You have to circle this on your test also because that is the factorized form. It has 1, 2, 3, 4 factors and 4 solutions. Number 4. Here's my 2 points. I have Z1 is 7, 2i, and I have Z2 is up here. So what is the distance between them? Well, it's going to be Pythagorean theorem. If you subtract them, you can use Pythagorean theorem. What is the midpoint? If you add them, you get the midpoint. And the neat thing is if you plot this midpoint over 3 up 5, it's right there. It's right in the middle of the points. Numbers 4, then 5. I have this number, and I'm going to convert it to trig form. Well, there's my number. I did it in radians here. And what this means, remember, if this is our number, it's a good form of it. However, it's just not simplified. Root 80 is 4 root 5. And the angle 1.0 means that if this is my angle, it's a turn that far down. So it's a turn of 1 radian past pi. So you have to add pi to it because we're looking for this large angle here. And that large angle is bigger than pi. So that's how we get those numbers. Number 6. I have this equation here, and I'm asked to plug in 3 plus I there and there. So I plugged it in there and there, and now I do the computation with it. Number 7, polynomial with the roots. 0, minus 3, minus 5i plus 5i. Foil those and those. Looks like this. Number 8 says factor it, and there's factored, and I factored it further, and I have solutions. Number 9, it gives you a formula, and it tells you what the E is, and it tells you what the Z is, so we're solving for I. So I'm going to divide this number over here, and now I have to divide this complex number by this complex number. Well, in the world of complex, this is how we do it. We multiply it by the conjugate, and it will come out down here. All right, on the back, number 10. Multiplying trig numbers is a very easy process. Multiply these, add those, but then now it says on number 10, if you look at it, it is a 2-step process. We simplify, then convert. I simplified, now I convert, so I just take this and distribute it here. Well, what do you know? Those are on the unit circle. Number 11, I plot them, add them, graph the result. Number 12 is De Moivre's theorem. I have this here, and I changed it to polar form. I did degrees, just because when I did this on my calculator, I did inverse tangent of 2 divided by 2. There's my answer in degrees, but if I change it to radians, watch what happens now. Inverse tangent of 2 divided by 2. This number is a lot easier to work with. You have your choice in the problem what you want to work with, and sometimes radians are easier, sometimes degrees are easier. In this case, degrees are easier, so I went with degrees. And then I did De Moivre's theorem. The 8 goes there, and the 8 goes there, and did the work. I want to show you one problem a lot of people were having here. If I simplify this to 2 root 2, and I do 2 root 2 squared on my calculator, I get 4. However, if I do 2 square root of 2 and I square the whole thing, now I get 8. The bottom way is the correct way to do this. If you're going to use an exponent with a number and a root, you must put it in parentheses. So make sure you put parentheses around all of that. Number 3 is a quadratic formula. Number 4, again, going to factor it by grouping, simplify, and if you have 2x plus 1, you can factor out a 2 here. And I have negative 1/2, root 18 simplifies down here. Number 15, I divide them, and then I simplify them. 15, this is a square root of a complex number. It's kind of difficult to do. So I take it and I write it to the half power, and once I see it written like this, in my brain I think De Moivre's theorem. So I can change it to a polar form. This should have been 67. 67. And I'll show you on here. Let's go ahead and get that. Inverse tangent. Let's put it in degrees. Inverse tangent here. Inverse tangent of negative 12 divided by 5 is that. So now watch. 13 raised to the power of a half times cosine of 0.5 times. On my calculator, I can just pull that answer down there. You might have to save it on your calculator. Press enter, and that's where the 3 comes from. And now I press again, and I do sine. But usually we have like the power of 8 there, and we multiply by 8. But here I'm doing 0.5 and that one. Oh, I used the wrong answer there. I needed to use that one up here, so let me do it right for you. Let's see, tangent of negative 12 divided by 5, 13 to the 0.5, sine of 0.5 times the answer now it will give me the negative 2. All right, 17. Every 4 i's is 1. If I were to think about that and I draw it out, I. 2 i's is negative 1, and that makes 1. So if I have so this becomes 1. If I have 55 divided by 4, I have 13 1's and 3 left over. So I have 3 left over here, and that is a negative 1 and an I, negative I. So this becomes 1, and that becomes negative I. I can FOIL these together, FOIL those together, and then I can simplify down to 17 minus I. And the last one, if you're taking the absolute value of a number, what absolute value means is distance from 0. If I do the absolute value of 7 is 7, because from 0 to 7 is 7 spaces. If I do the absolute value of negative 7, well, that's over here, and that's also 7 from 0. But what if I do this point down here and I need this distance down here? Well, how do I find the distance, not to 7 or negative 7, but the distance this way? Well, that is a right triangle problem, and this is a squared plus b squared equals c squared. 7, 24, 25 is the distance. In this case, it's the absolute value. They mean the same thing. All right, I hope this helps. If you have any questions, see me in class.